Welcome to The Explainer. Today, we're going to tackle something that trips up pretty much every single new Java student: how in the world objects are compared. We're going to clear up the confusion between double equals, dot equals, and hashcode. And trust me, this is a skill you absolutely need to write good Java code.
So here's our game plan. We'll kick things off with a super common trap that involves strings. Then we'll check out some more advanced ways to compare objects, learn how to give them useful descriptions, and then, oh yeah, we are diving deep into the critical contract between equals and hashcode. We'll wrap it all up with some golden rules that'll make this stuff second nature. All right, first up, the single biggest mistake new Java developers make. And seriously, don't feel bad. We have all been there. It all starts with comparing strings, and it's where so many bugs are born. So take a look at this little snippet of code. We've got two string variables, s1 and s2, and they both hold the text hello. Now, your brain is probably telling you that s1 equals s2 should print true, right? I mean, they're the same. But if you actually run this, you get false. So, what on earth is going on here? This slide right here, this gets to the absolute heart of it. The double equals operator, equals equals, checks for what we call reference equality. It's basically asking, hey, are these two variables pointing to the exact same spot in memory? It cares about the address. The dot equals method, on the other hand, checks for value equality. It's asking a totally different question. Do these two things hold the same content? For a string, that just means, do they have the same characters in the same order? Now, the reason this is so tricky is because of a clever Java optimization called the string pool. See, when you create a string like s1 equals hello, Java puts it in this special memory area. If it ever sees hello again, it just reuses that same object. Super efficient. But the moment you use that new keyword, you're telling Java, hey, forget the pool. I want you to build me a brand new object on the heap. And that's exactly why our equals equals comparison failed. There were two different objects in two different memory locations. Okay, so let's build on that idea. Because in the real world, just knowing if something is equal or not equal often isn't enough. A lot of the time, you need to know how things should be ordered, especially when you start dealing with text from all over the world. And Java gives you a whole toolbox for this. You've got your basic dot equals equals for an exact match, case and all. You've got dot equals case ignoring when you just don't care about capitalization. For simple alphabetical sorting, there's dot compare to. But the real professional grade tool here is collator. If you need to sort text that has accents or follows different rules, like in French or German, collator is what you need to get it right. It actually understands the local language rules. And this, right here, this is a habit every single professional Java developer needs to get into. If you try to call dot equals on a variable that happens to be null, boom, your program crashes with a big ugly null point exception. But if you use this handy utility method, objects.equals, it takes care of the null check for you. No crash. It's such a simple change, but it makes your code way more robust. Okay, so we've covered strings, which are built right into Java. But what about the objects that you create from scratch? Let's talk about how to give your custom objects a useful, human-readable description. This is a super important distinction to make. The whole reason the toString method exists is to help you, the developer. It's for getting a clear picture of an object's state when you're looking at logs or using a debugger. It is for human eyes, not for your program's logic. So let me say this again. Never, ever, ever use the output of toString to check if two objects are equal. And here is a perfect example of what I'm talking about. By overriding toString in this book class, you turn your log output from some gobbledygook like book at 1A, 2B, 3C, 4D into a clean, clear description of the book's data. This is so incredibly valuable when you're trying to hunt down a bug. All right, let's get serious. This right here is the absolute core of our explainer today. This is the unbreakable, non-negotiable contract that governs how your custom objects behave. If you can get this right, you are well on your way to becoming a fantastic Java programmer. The contract itself sounds simple, but you cannot break it. It goes like this. If two of your objects are considered equal according to your dot equals method, then their hashcode methods must return the exact same number. If you violate this rule, data structures like hashset and hashmap will completely break down in really weird and confusing ways. This table spells it out perfectly. When equals and hashcode agree, everything's great. Your collections work just like they should. But when they disagree, well, things get broken. You might put something into a hash set, And then when you go to look for it, Java tells you it's not there. Or you might end up with duplicates where you're not supposed to. It's just total chaos for your data. So let's actually see this contract in action. It'll make more sense. Imagine we have a person class. We're going to create two separate person objects in memory. We'll call them P1 and P2. But we're going to give them the exact same data, same ID, same name. So for all intents and purposes, they represent the same person. Now we're going to take both of these equal objects and try to add them to a hash set. Now remember, the whole entire point of a hash set is to only store unique things. It's supposed to prevent duplicates. And what happens? The final size of the set is 1. Perfect. The hash set correctly saw that P2 was a duplicate of P1 and just ignored it. This only worked because the person class followed the contract. The set first checked their hash codes, saw they were identical, and then, as a final confirmation, it used .equals to be absolutely sure they were duplicates. That is the contract working exactly as it should. Okay, let's bring this all home. We're going to wrap up by looking at a really cool modern Java feature that makes this whole thing way easier. And then we'll put your knowledge to the test with a quick quiz. This is a total game changer, especially for you as students. For those simple classes that are really just containers for data, like a point or a person, you can use something called Java records. With this one little line of code, Java automatically writes perfect contract-abiding equals, hashcode, and toString methods for you. It is the best, safest, and by far the easiest way to do this. All right, quiz time. Quick check. We saw this one before. Is this line of code going to print true or false? And the answer is false. You got it. Remember, equals equals is all about the memory address. That new keyword is your big clue. It always forces a new object to be created, so they can't possibly have the same address. Okay, next one. True or false? It's totally fine for two objects to be considered equal by the .equals method, but have different hash codes. That is absolutely 100% false. No way. This is the classic mistake we've been talking about. It directly violates the equals/hashcode contract, and it is a one-way ticket to buggy, unpredictable behavior in your collections. So let's just quickly recap the golden rules. For string content, always use .equals, never equals equals. Remember, toString is your friend for logging and debugging, but it's not for checking equality. And the big one, if you override equals equals, you absolutely must also override hashcode. Or even better, if you're just making a simple data class, use a Java record and let the compiler do the hard work for you. So as you go on to write your own code, always keep that last question in mind. How will you make sure your next class gets these rules of identity right? Thanks for watching.